So the question was asked if this piece of metal, this curved piece of metal I have in the tank, is affecting the curve of the laser beam and the curve of the visible light from the target. And the answer is no, it isn't. And I know it isn't because the metal doesn't actually go all the way across the tank. It's just in the middle part of the tank. There's quite a large section on the side, several inches wide, that is not covered by that. And so if I look down below the waterline, you can kind of see that here. Here's the scene from before. I've added some more obstructions there, and there's Chicago in the distance. And I've added over here. I've added on the right hand side. I've added a bit more skyline because there wasn't enough there to demonstrate it. Now, if we look off to the side, like where there is no curve, it's just seabed, as it were, or the flat ground of an imaginary flat Earth, and you see you get the exact same effect as before. You get the compression, and it doesn't really make any difference if we're doing it over this flat section or if we're doing it over this section over here. The compression is basically the same, and we can demonstrate the laser beam. I'm doing it here on this flat section here, and the curve is basically exactly the same. And I'm doing it perfectly straight. Doesn't matter if I'm going up a little bit, down a little bit. The beam always bends, even though the temperature gradient is actually perpendicular to the beam. It's a little counterintuitive because you think that, because you're not going through a change in any medium, you're going to essentially you're sliding between two different refractive indices here. You think it wouldn't bend, but that's not the way it works. Light acts like a wave, and the wave gets turned by the gradient. So there you are. It is not related to this curve, the curving of this laser beam. It's just to do with the gradient refractive index.